Question number 2. How many ordered pairs of numbers xy are there where xy belongs to the natural number set 1 to 100 such that x minus y modulus is less than or equal to 50? So before we start this question, I would like to talk to you about two things. The first one is ordered pairs. Now some of you might know this, but I would still like to clarify this. An ordered pair is a pair in which the order matters. So 1 comma 2, this pair is not the same as 2 comma 1. We will have to count these as two different pairs. Alright, now I want to talk to you about the modulus function. The modulus function, you might know how to break down a modulus function to make it easier to solve, but I want to talk to you about its intuitive meaning. So say you were to calculate the distance between two places, place A and place B. Now if you put your measuring stick from point A, from place A up till place B, say it reads 5 units. So you'd say that the distance between A and B is 5 units. But if you were to start measurement from the point B, and move till the point A, you'd again get 5 units. You're just flipping the scale. But that does not change the distance between these 2 points. So to measure the distance between 2 points or between 2 places, the modulus function was invented. So the distance between 10 and 5 is given by the modulus of 10 minus 5, or by the modulus of 5 minus 10. These two must mean the same thing because you're just measuring the distance between 10 and 5. So that's what the modulus function does. So anytime you see the modulus function, you should imagine the distance between two numbers. Now sometimes you might get something like the modulus of minus 10. What it really means is that it is the distance of the point minus 10 from 0. So the modulus of minus 10 is just 10 because the distance between 0 and minus 10 is 10. Alright, so now let's start with our question. Okay, so there are several ways to do this. You might want to break down a modulus function such that when into cases when x is equal to y, or when x is greater than y, or x is less than y. But I am going to do it in a different way. I'll take all the values of x and then look for corresponding values of y such that our inequality holds. Okay, so let's say I take x equal to 1. Now I'm looking for all those y's such that x minus y, the modulus of x minus y is less than or equal to 50. And I'm only allowed to choose numbers from 1 to 100. Right, so when I've taken 1, you need to think of another number such that its distance from 1 is less than or equal to 50. So y can be either 1 or 2 or 3 or up till 51. Right, so if I choose y to be 3, the distance between 1 and 3 is just 2. So it will satisfy our inequality, the required inequality. And now I'm going to count these number of ordered pairs. So this is our count, and obviously it would be 51. I would have pairs such as these: 1 comma 1, 1 comma 2, 1 comma 3, and so on and so forth till 1 comma 51. Right, and we would get 51 pairs. Now if I take x to be 2, I again need to find numbers such that x minus y, the modulus of x minus y, is less than or equal to 50. So I can take y to be 1, 2, 3 and up till 52. Now this time I would have 52 pairs. Okay, so we can keep going on like this for different values of x up till the point when x is actually equal to 50. So when x is 50, y can be 1, 2 up till 100, and we will have 100 ordered pairs in this case. Now after this point, when x becomes 51, y can again be from 1 to 100, and you'll again have 100 pairs. But when x is 52, y can no more be 1, right? Because when y is 1, 52 minus 1 would give me 51, and it won't satisfy a required inequality. So I'll have to start from the number 2 up till the number 100, and this time I would have 99 pairs. And then when x is 53, we'll have to start from 3 up till 100, and I'll have 98 pairs, and so on and so forth till when x is 100. So when x is 100, y is allowed to be 50 at max, at min that is, and this is again 51 pairs. So all I need now is the sum of all these counts. I just need to sum all these numbers, and I would have the total number of ordered pairs. There would be no repetition because we have been following x in an increasing manner. So the first term in the ordered pair is always changing. So there's no case of repetition. I just need to add all of these. Now to add all of these, you can see that there are two different series. So the first series goes from 51 up till 100, and the next one goes from 100 to 51. So obviously both of these are the same, they are just flipped around. So the sum of all these numbers is just twice the sum of one of these series, and each of these is an AP, an arithmetic progression. So the series starts from 51. I'm talking about the first series here, and the last term in the series is 100. The number of terms is 50. So the sum of the series, I need to calculate the sum of the series and then multiply it by 2 because I have two of these. So that's a very basic formula that you should know. And I'm just going to input these values. If you were to calculate this, it would turn out to be 7550. So this is our answer, option C.